Hello and welcome to Dove Biology APES Lessons to Go. In this video, we'll be exploring global climate change. Climate is defined as a region's general pattern of weather, including seasonal changes. Two main determinants are going to be our average temperature and precipitation. If we take a look at this diagram here, we see that over the course of time, the weather can change. The weather represented by our little blue wiggles here. But our average pattern of weather, the green line, is pretty consistent over long periods of time. Now, the Earth's climate is the result of three main factors: solar energy, the greenhouse effect, and atmospheric and ocean circulation. The sun's rays will hit the equator at direct angles between 23 degrees north and 23 degrees south latitude. Radiation that reaches the atmosphere here is going to be the most intense. In all other cases, the rays are going to arrive at an angle to the surface and are much less intense. The closer a place is to the poles, the smaller the angle, and therefore the less intense the radiation. As air circulates from the tropics to the regions approximately 30 degrees north and south latitude, where the air masses sink, this belt of air circulation is referred to as a Hadley cell. Two additional belts of circulating air exist in the temperate latitudes and near the poles. Under the influence of Earth's rotation, air returning to the surface is deflected by the Coriolis force, which shifts the flow of air to the right of its initial trajectory in the northern hemisphere and to the left of its trajectory in the southern hemisphere. Winds blowing towards the equator are going to be deflected to the west, creating our easterly trade winds. In the temperate zones, where the winds blow toward the poles, the Coriolis effect is going to deflect them towards the east with the prevailing westerlies. Just as the Earth's rotation creates the prevailing winds, it also creates surface currents within the oceans. Under the influence of trade winds, surface waters near the equator flow from east to west, as in the atmosphere. The Coriolis force causes the water to be deflected away from the equator, northward in the northern hemisphere and southward in the southern hemisphere. This Coriolis effect sets up a rotational convection within the oceans, and currents typically flow in a clockwise rotation in the northwest hemisphere and in a counterclockwise direction in the southern hemisphere. As it reaches the poles, the water will cool and sink. Prevailing winds in the northern and southern latitudes help to create cold water surface currents and flow back towards the equator along the west coast of the continents. The greenhouse effect is the result of particular gases that are found in our stratosphere, like carbon dioxide, ozone, methane, nitrous oxide, and CFCs. These are designed to absorb the radiated heat that are coming off the planet and keep our atmosphere warm. Unfortunately, the more greenhouse gases that we produce, the higher the atmospheric temperature. Now, scientists have been able to piece together a picture of Earth's climate dating back hundreds of thousands of years by analyzing a number of indirect measures of climate, like ice cores or tree rings, glacier lengths, pollen remains, and looking at ocean sediments. We actually have extremely detailed climate readings beginning in the mid-1800s. The historical record shows that the climate system has varied naturally over a wide range of timescales. Over the past 900,000 years, the atmosphere has experienced prolonged periods of global cooling and warming. These cycles of freezing and thawing are known as glacial and interglacial periods. Recent climate changes, however, cannot be explained by natural causes alone. Research indicates that the natural causes are very unlikely to explain the most observed warming, especially warming since the mid-20th century. Rather, human activities can very likely explain most of that warming. For example, if we look at the increase in atmospheric carbon dioxide since the 1900s, it corresponds pretty well to an increased global average temperature. Global temperatures have warmed significantly since the 1880s, the beginning of what scientists call the modern record. At this time, the coverage provided by weather stations allowed for essentially global temperature data. As greenhouse gas emissions from any production, like industry and vehicles, have increased, we've actually seen temperatures climb, most notably since the late 1970s. In this animation from NASA, we see temperature data from 1880 to 2011. The reds will indicate temperatures higher than the average during a baseline period of 1951 to 1980, while the blues will indicate lower temperatures than the baseline average. As a result, there is significant scientific consensus. Over 97% of climate scientists think that global warming is significant and likely due to human activity. The International Panel for Climate Change and the U.S. National Academy of Sciences, the American Geophysical Union, have all projected with a 90 to 99% probability that Earth's temperatures will increase by between 2.4 to 5.4 degrees Celsius by 2100. Now, there are a number of feedback systems that are going to impact our climate. There are positive feedback systems that can actually amplify or increase changes in our tropospheric temperature. These are going to be harmful and are unfortunately more common than negative feedback systems. Negative feedback systems can actually decrease the changes in the tropospheric temperature and act as a corrective to kind of bring things back to a set point. One of those systems that can act actually as both a positive and a negative feedback would be oceans. Oceans can act as a negative feedback system by helping to moderate the Earth's temperature by storing heat, because water has a high heat capacity, and by absorbing excess carbon, acting as a carbon sink. Unfortunately, as the Earth warms, the ocean will turn into a positive feedback system. With a warming ocean, the solubility of carbon dioxide is going to decrease. So increasing ocean temperature actually causes carbon dioxide to bubble out of the ocean and into the atmosphere, increasing global warming, which then would increase the temperature of the ocean, causing more carbon dioxide to be released, producing more warming, and so a positive feedback system. Clouds can also act as both a positive and negative feedback system. Clouds could have a positive feedback if they're formed really high in the atmosphere. If they're formed high in the atmosphere, they can absorb and release heat back into the troposphere. But if clouds form lower in the atmosphere, they can actually act as a negative feedback system and cause a cooling effect by being able to reflect more sunlight back into space. Outdoor air pollutants can actually act as a feedback mechanism. Depending upon their size or reflectivity, they either can reflect sunlight and heat, or they can absorb sunlight and heat. In general, most aerosols, though, won't have a major effect on climate, since they'll fall back to Earth in a relatively short period of time, and their levels are already being reduced as a result of Clean Air Act and other air pollution measures. Snow and ice can also act as a feedback mechanism. Typically, snow and ice have a high albedo and reflect solar energy, helping to cool the Earth. As the Earth warms and ice melts, the darker Earth underneath is going to have a much lower albedo, and so it's going to absorb more of the heat that's coming from the sun, which is going to warm the Earth, causing more snow melt, resulting in a positive feedback mechanism. If instead there were a way for us to have more snow means more sunlight reflected, which means a cooler Earth, which means more snow, which means a cooler Earth, a negative feedback mechanism. Now, as the Earth warms and climates begin to change all across the planet, there are inevitably going to be consequences. There's going to be consequences in terms of human health. As people in areas are prepared for changes in extreme weather, and so we'll have weather-related mortality. Environments might be more conducive for certain parasites or pathogens, and so people that don't have built-in immunities to those pathogens and parasites are now going to be experiencing more infections. As climates change, areas that once were able to support crops will no longer be able to, and in other areas, in order to maintain agriculture, they'll have an increased demand for irrigation. Our forests exist in particular locations because of the climate. As climate changes, the overall forest compositions are going to change. And where those forests can grow will also change. And our overall forest health and productivity is going to decrease, which is going to impact the biodiversity that relies on those forest ecosystems. As climate change is going to disrupt weather patterns and precipitation, groundwater and surface water recharges. As a result, water supplies are going to change, and many areas will not have water that they once had. We'll see a decrease in overall water quality and likely an increase in competition for water resources. Along coastal areas, as a result of seawater rise, we're going to have erosion of beaches, flooding of coastal lands, and additional cost if we want to maintain coastal communities. And then finally, our natural biodiversity and species richness is going to be impacted. As habitats are disrupted, we're going to have a loss of species. With climate influencing many national economies with the production of agricultural and textile goods, governments will need to play a role in reducing climate change. There are three major strategies that they might employ in order to do so. One might be the initiation of carbon taxes or energy taxes, which would tax each unit of carbon dioxide emitted by fossil fuel burned or each unit of a fossil fuel burned. Governments may try to level economic playing fields by increasing government subsidies for energy efficient technologies or carbon sequestration or even sustainable agricultural techniques. We may use technology transfers, where governments in a developed country could give renewable energy technology to developing countries at a low cost or perhaps even for free. Critics, though, say that taking these kinds of measures to combat global climate change could actually hurt the economies too much to actually be useful. One can see the effect of economics on decisions with regards to climate change is with the Kyoto Protocol. In 1997, we had our first negotiations of international legislators to try to reduce the amount of greenhouse gas emissions. The U.S. did not sign on to the Kyoto Protocol because it cited that harm to the U.S. economy would take place because of the exclusion of developing countries that have high emissions like China, India, and Brazil. Moving forward, we really only have two basic strategies for dealing with global warming: mitigation or adaptation. With mitigation, we can actually improve our energy efficiency, rely more on carbon-free renewable energy resources, and find ways to keep carbon dioxide out of the atmosphere. All of these strategies would be enhanced by reducing population and also reducing poverty. With adaptation, we can recognize that global warming is inevitable and devise strategies to reduce its harmful effects, like connecting wildlife reserves with corridors so that as climates change, populations will have a way to escape those changing climates. We might stockpile key supplies of food or maybe prevent new construction in low-lying coastal areas. Most experts think that probably a mix of both approaches is going to be needed. Some are even considering a plan B. If things get so bad and we need to rapidly reduce the temperatures in our atmosphere, to come up with ways to geoengineer our planet. Maybe seeding clouds at low levels to try to push back more of that solar energy. Maybe fertilize the ocean with iron so that it would take up more carbon dioxide. Build artificial carbon sequestration mechanisms like artificial trees or pumping carbon dioxide deep into geological formations. Some suggest putting aerosols into the stratosphere by exploding bombs high up in the atmosphere. We could perhaps start painting things more white to try to increase the albedo of the planet so that less sunlight and less heat is held in. Climate change may seem like a daunting problem, but everyone can do their part to help. For traveling, we could use fuel-efficient vehicles and public transport, or even walk or ride a bike. At home, we can switch to more energy-efficient lighting and appliances and use passive solar energy to dry our clothes or heat our water. We could support local agriculture so that we can reduce the distance our food needs to go from farm to table, which is going to reduce the amount of fossil fuels needed for their transport. We can purchase fewer things, which is then going to reduce the amount of energy that was needed to produce them. We can eat less meat, which not only is going to free up more agricultural land, but also reduce unnecessary greenhouse gases produced in the production of meat products. And above all, we can be an advocate for reducing our carbon footprint so that by little bit, we can reduce the impacts of the greenhouse effect and hopefully have a more sustainable future for everyone.